The story of nuclear weapons begins with a design that was almost deceptively simple. The first nuclear weapon ever built was known as the Gun-Type Fission Bomb. Inside the weapon, a conventional explosive fired one piece of highly enriched uranium down a narrow tube into another piece of uranium. When the two pieces collided, they formed what scientists call a critical mass, triggering a powerful nuclear chain reaction. The United States used this design in a bomb called Little Boy, dropped on Hiroshima in August 1945. Despite its historic impact, the weapon was never tested beforehand. Scientists were confident it would work, and they were right. Soon after Hiroshima, engineers realized the gun-type design had serious limitations. It wasted nuclear material and could not work with plutonium. Scientists quickly developed a new approach known as the Implosion Bomb. Instead of firing two pieces together, this design placed a sphere of fissile material at the center of the weapon, surrounded by carefully arranged explosives. When they detonated, the blast compressed the core inward from every direction at once, forcing it into a supercritical state. The bomb dropped on Nagasaki, known as Fat Man, used this implosion method, which later became the foundation of most nuclear weapons. Once fission bombs existed, scientists began asking a bigger question. What if one nuclear explosion could trigger an even larger one? The result was the thermonuclear bomb, or hydrogen bomb. In this design, a fission bomb acts as the trigger, creating temperatures and pressures so extreme that hydrogen isotopes fuse together. Fusion releases far more energy than fission alone. The United States tested the first hydrogen bomb in 1952, and the Soviet Union followed shortly afterward. The most powerful nuclear weapon ever detonated was the Soviet Tsar Bomba. Tested in 1961, its explosive yield reached about 50 megatons, making it thousands of times stronger than the Hiroshima bomb. The fireball could be seen from hundreds of kilometers away, and the shockwave traveled around the Earth multiple times. It was less a practical weapon than a dramatic demonstration of Cold War power. Between basic atomic bombs and full hydrogen bombs lies another design called the boosted fission bomb. In this system, a small amount of hydrogen isotopes is injected into the fission core. When the weapon detonates, a brief fusion reaction releases additional neutrons, dramatically increasing the efficiency of the fission process. This allows modern nuclear warheads to produce large explosions while remaining compact. During the Cold War, engineers also explored the concept of the neutron bomb. Instead of maximizing blast damage, this weapon was designed to release intense neutron radiation while reducing the size of the explosion. The idea was to disable soldiers inside tanks and armored vehicles without completely destroying nearby structures. The concept was controversial and became a symbol of how nuclear strategy was evolving. Not all nuclear weapons were meant to destroy entire cities. Many were designed for battlefield use and became known as tactical nuclear weapons. These smaller weapons had lower explosive yields and shorter ranges. They appeared in forms such as artillery shells, short-range missiles, depth charges, and even portable nuclear devices carried by special military units. As missile technology advanced, nuclear weapons evolved as well. Intercontinental ballistic missiles, or ICBMs, made it possible to deliver nuclear warheads across continents in minutes. Engineers later developed systems capable of carrying multiple warheads on a single missile. This technology, known as MIRV, allows one missile to strike several targets at once. Another major shift came from beneath the ocean. Nuclear submarines introduced the idea of survivability. While land-based missiles can be tracked and targeted, submarines can hide in the vastness of the ocean. This created what strategists call second strike capability, meaning that even if a country is attacked first, it can still retaliate with nuclear force. Not all nuclear threats involve nuclear explosions. One example is the dirty bomb, which combines conventional explosives with radioactive material to spread contamination over a wide area. The blast itself may be small, but the psychological and economic impact can be enormous. Since 1945, humanity has lived in the nuclear age. Weapons capable of destroying entire cities in seconds now exist in the thousands. Their presence has shaped global politics, military strategy, and international diplomacy for decades. Yet despite their terrifying power, the hope has always remained the same, that these weapons will never again be used.